One thing that is absolutely important to recognize with hydration is that there's a lot of individual variation with this. So if you have two people that are consuming the same amount of fluid during a workout, we cannot assume that they are equally hydrated. There are differences in sweat rates. In particular, body size does play a role in that. Genetics play a role in that. So we want to take every athlete on a case-by-case basis. One way that we can do that is by calculating individual sweat rate. Also keep in mind that sweat rate will change even in that same person, depending upon their level of training, depending upon the environment. So anytime you have a shift in environment, it's good to do this calculation. I would do it also periodically through a season as those training adaptations start to take hold, their sweat rate might change also. So doing this every now and then is going to be good just to determine what an individual's hydration needs are. So how you're going to do this is you're going to take a body weight before and after exercise. The best way to do that is a nude body weight, meaning naked, no clothes, because clearly clothes have weight to them, but after a workout, they might be saturated with sweat, and that might throw off your measurements. So make sure the person is dry and unclothed or minimal clothing if at all possible, if nude weight is not possible. And then you're gonna determine what that change in body weight is. So in this example you see here, before exercise is 180, after exercise is 174. That person lost 6 pounds of body weight over the course of that workout. 6 times 16 gives us 96 ounces. Okay, everything we're doing with hydration is gonna come back to ounces. So that's why you need to convert that pounds into ounces. You with me? All right, cool. So the next thing we're gonna look at is how much fluid did that person take in during that workout? In this example, it's 16 ounces, right? So we're gonna have to factor that in because they're putting that fluid into their body. That will skew a bit what our change in body weight is. We have to factor that in. The other thing we're gonna wanna factor in is urine. If there is any sort of urine output, that's water out off the body. So we wanna take that in. My recommendation is this. Unless you feel like collecting urine from that person and measuring how much volume there is there, I would recommend just leave that part out. Have them not urinate during that workout if at all possible, or pick an exercise time that's short enough that this won't factor in. But if that person's really got to go and you're really trying to use this as your measure for sweat rate, then you're going to collect that volume and measure it. For our example and for practical purposes, we're probably going to keep that at 0. Okay. So now what we're going to do to determine sweat loss is we're going to take our change in body weight in ounces. You're going to add in what that drink volume was, which is 16 ounces, and we're going to subtract the urine volume. So when you take 96 plus 16 minus 0, we get 112 ounces. Okay. So that's how much fluid was lost during this workout. Okay. So now we're going to look at the exercise time. In this example, it's 90 minutes. So we take 90 minutes and we compare that to our 112 ounces. So you're going to take 112 ounces divided by 90 minutes. That means that this person has a sweat rate of 1.25 ounces per minute. So every minute that person is exercising, they're losing roughly 1.25 ounces of fluid. Okay, so now we know what their sweat rate is. That's their sweat rate. Okay, but what's important to know is that you don't need to be taking in 1.25 ounces every single minute. Okay, what's interesting and very, very practically helpful about hydration is that you only need to stay within a 2% body loss. Anything greater than 2% of body weight loss due to hydration impacts performance negatively. If a person is less than 2% body weight loss, their performance is not going to be impaired, okay? So we don't have to meet 100% of the needs, we just have to stay within this window. So if you have a person, in this current example, that's 180 pounds, and we're trying to stay within a 2% body weight loss, that means maximally they should be losing 3.6 pounds of body mass. And that doesn't really matter what their workout time is, that's at all, okay? So in this scenario, that means that this person only needs to be taking in 0.64 ounces per minute to put us close to that 57.6 ounces for the exercise time of 90 minutes in this scenario. okay? Keep in mind, we do everything in ounces. So you convert that pounds into ounces, that's where you're getting this 57.6 from. Dividing that by 90 minutes, that means you're getting 0.64 ounces per minute. So you do not need to replace 100%. Essentially, you're going to be replacing enough to stay within that 2% body weight loss, okay? Do these examples on your own. Use yourself. Just throw some numbers in here and get some practice with calculating this. I promise you with 100% that this is going to be on your exam. So please make sure that you're comfortable with this well before the exam actually happens.